In this video, I'm going to be using the distributive property. And I don't particularly love the name of this. I'm just going with what our book says. So I'm going to cross that off. Really, what I'm going to be doing is I'm going to be factoring using the greatest common factor, or said another way, the GCF. Okay, we're going to be looking at these terms and factoring out the GCF, the greatest common factor. Okay, use the distributive property to factor out each polynomial, factoring out the GCF. Okay, so what you're going to do is with the numbers, you're going to look and see what's the largest number that goes into both 5 and 15. I'm sorry, 15 and 25. I was already thinking about it. The number 5 goes into both of those. Now for your variables, what you have to look at is you have to look at those x's and you go with the one that is the lowest exponent. So now you have to think, okay, what's left over? 5x times what is going to get me 15x? Well, that's 3. 5x times what is going to get me 25? Well, 5 times 5 is 25. 5x times 5x times x gets me an x squared. So what you can always do is you can always distribute this back through. So this would be your full answer, but always check your work. If I distribute that back through, I should get what I had up here, which I do. Okay, for B, we have to see what's the largest number that goes into both 8 and 40. I don't know why I don't trust myself. Yep, 8 goes into 40. And then remember what I said about the variables. So for your variables, pick the lowest of the exponents. So 8n squared, well, 8 times 8, so that's going to be a 1 there. N, remember, you're adding the exponents when you multiply. So basically you're doing 6 minus 2, well, that's a 4. Because n squared times n to the 4th gets me back my n to the 6th. Minus 40n squared, 8 times 40 is a 5. And then if I were to do 8n squared, if I were to so this would be my answer, but if I were to redistribute it back in, you should get what we get up here. Okay. Use the distributive property to factor each polynomial. So now we have more than one variable in here. So we have to look here between the 2, and the 12, largest number that goes into all three of those. Well, that's going to be a 2. X, no other terms have x's, so I can't factor any x out. But between your y's, y to the 4th is the highest, or is the lowest exponent, I should say. So this first term, 2 y to the 4th, I need what's left over? An x, because I factored out both of these pieces. I factored out the 2. I factored out 4 of those y to the 5th, so I have 1 left. And then minus, if I divide, when we're factoring things out, we're really dividing each term by that number. So if I have 12 divided by 2, that's a 6, or 2 times 6 is going to get me back 12. Y to the 4th, I've already factored that out. So that's what that one is. So this next one, largest number that goes into 12, 24, and 30, that's 6. Now look at your x's. The lowest power on your x's is x. the lowest power on your y's is y. So now, 6xy times what is going to get me back to 12xy? Well, all I have left over is a 2. 6 times what is going to get me to 24? Well, that's 4. I factored out that x. Y times what is going to get me y squared? That's y. I factor out a 5. Let me think about this differently. X times what is going to get me x squared? Well, that's an x. Y times what is going to get me y to the 4th? Well, that's y to the 3rd. And both of those are done. Again, you can always multiply these back through if you want to see if your answer is correct. Okay, factoring by grouping. I really like factoring by grouping. You use grouping when you have 4 terms. And quite honestly, in an Algebra 1 class, I'd probably tell you guys, use factoring by grouping. So, what you do is you group the first 2 terms together. And regroup the second 2 terms together. So the first 2 terms, factor out your GCF. So I have a 7 goes into both. That's the highest number. Lowest variable. I was thinking about, I don't know why I was thinking about 4. X squared. So I'm left with a 3x. I'm going to change the color on this. I'm changing the color for a reason. I'm left with a 3x plus 8. Did that work out right? Okay, so right now I'm going back through and I'm checking, yep. So now, this next term, largest number that goes into each one of those is a 5. You always take the same sign. That's going to mean something to us. 5. What's left over? 3x, because 5 times 3 is 15x, plus, basically I take 40 divided by 5, and that's going to be an 8. Now, what you have here that's kind of hard for some students to see, you technically have one term times by another term. So what we have here is we really have a greatest common factor another time. So what's my factor? The factor that's common in both is this 3x plus 8. I factor that out of each one. So what's left over is 7x squared plus 5. Okay, so you factored out that 3x plus 8. I always have students every year when I used to teach this in my Algebra 2 class. Well, what happens to the 3x plus 8? It gets factored out. What happens to the second one? It's gone. No, it's been factored out. It's right here. Because if I were to take this whole term and distribute it back to each one of those terms, you'd get what you have above. Okay, another factoring by grouping. Again, that's kind of a fun one. I'm never going to mess with you guys where you have to factor the first, where you have to rearrange the terms, okay? Some teachers like to do that too. I am not going to do that to you. I think that's too confusing. So in these first 2 terms, what's common? Each one has an x. There's no commonalities between the numbers or the y's. So that's all I could factor out. So I'm left with a 2y plus 7. So something that I didn't highlight in the last one, I'm going to go back to the last slide. this 3x plus 8 has to be the same thing in that first and last term. So that has to be the same thing. Going to this example, basically I need 2y plus 7 out of this term here. Well, what do you notice? I kind of have it, I just have a negative and a negative. So if I factor out a negative 1, I'm left with, if I factor out a negative 1 from this 2y, that's a negative. If I factor out a negative 1 from 7, I have a plus 7. Now that 2y plus 7, that's common in both terms. So that kind of gets factored out, kind of, I don't want to say canceled out, but it gets factored out. And then I'm left with x minus 1. Okay, factoring this guy by grouping. Again, I want to highlight first two terms. You group together. Last two terms, you group together. So first two terms, factor out what's common. 3 goes into both, and there's an a in both. Now what's left over? 3a times 5 is going to get me a 15a. I have the 3, I already have a 3a here, so I factor that out. All that's left over is a b. Oh, this is a good one. This is one I didn't anticipate doing. Ooh. Now here, 4, what's left over? I have a b minus a 5. So, hopefully you notice I have a 5 minus b, a b minus 5. Those are the same term, just one of them is negative, one of them is positive. So if I factor out, technically from this one, a negative 1, so if I factor out a negative 1, that changes the sign of everything. So then now I have the common piece that I would be able to factor out. So I factor that out. What's left over? Kind of like canceled that out in each term. Negative 3a plus 4. Okay? So that is my video on factoring by using the greatest common factor.